Hello, we're going to talk about a round robin technique. Well, it's not actually a round robin, it's a similar approach to a round robin. And we're going to investigate, is it good to do this or is it not? And there'll be results at the end that goes into detail about ways that this can be beneficial and ways that it's not necessarily beneficial. So what we're going to do then, just to show something, so we can have something visual to gauge this against, is I have a spline and we're just going to visualize the points on each tick. So I have 10 points on this spline. So this is just a blueprint actor that I've created with a spline, and I've put a point at every 100 units. So let's just say this, and then get location of spline point, and then we're going to draw debug sphere. Just let's do that, and get actor tick interval. Just draw it for the amount of the tick, which our tick interval is 0.1. And we want that to be world, so let's just do that. So what we're going to do then, oh yeah, we need our index there. Okay, so every tick we're going to loop over 10 index and draw a sphere at the point on the spline. So essentially what's going to happen is it's going to draw a sphere sorry, at point 0, then point 1, then point 2, then point 3, then point 4, and point 5, and it's going to do that in a loop every tick. So let's just see what that looks like. So we can see here we have 10 spheres, and you know, this could be anything. Like, it could be getting some variable, it could be doing like ray tracing or something, or line traces. And the idea that we're going to explore now is, okay, maybe we don't need to do this this amount on each tick. Maybe we can just spread the CPU load a little bit. So what we're going to do then is we want to make a max value here. We want to make index value here. Call it round robin index. So we're just going to loop over this index value. So first and the last means it will just be, it's the same value there. And what we want then is, let's just make a max value as well. And what we'll do is we will increment so essentially we're going to increment this, add to it, and then we need to reset it again. So let's just do that. And then what we want to do here, here we go. So let's do a branch. Okay, so what am I doing here then? So every tick, I'm going to ask if the round robin index is equal to the round robin index max. If it is, then I'm just going to set it to 0, which acts as a reset. And if it's not, then I'm going to increment it. Okay. Like that. So, yeah. Each tick.
I didn't catch that.
Alexis.
Please say that again.
So what's going to happen then is each tick, our index value is going to ask what, and then it's going to add one to it. And then if it equals the same as the max, we're going to just set it back to 0 again. That looks to be okay. So fingers crossed, let's see what happens. There we go. So now we can see that instead of doing them all at the same time, we're cycling through the loop. So this might give us less CPU usage, basically. That's the intent here. But one thing that this might also cause is it might cause a little bit of inconsistency or delay on our result, because if we need to calculate, if we need to calculate all these together, it's going to take longer to get to that value now. So one thing we can do then is just speed this up. So one thing we can try is on begin play. Let's get our tick. And we're going to divide our tick by our index max. And then we're going to set our tick interval from that. So our default value is 0.1. We're going to divide that by our index max, and then we're going to set it, which then means each tick, this will be quicker. So the intention here then is, in 0.1 seconds before we were doing everything in 1. Now we're going to do it all in the same time as 0.1, but we're just going to spread those. We're just going to spread the load basically across the frame. So let's click play. And it does work, but it's going too quick for us to visualize. So what we need to do then is just unhook that, and let's just say, let's just draw it by 0.1, but let's do 0.05. Let's see if we can see that. There we go. So there we go. We now are, if these were line traces or anything else, we're essentially splitting the load, which may or may not be a good thing, and we can do some exploring of that next. Okay, so I've captured this data in Unreal Insights as well, just to see the results. So in this 30-second window, we can see that our blueprint, which wasn't using the round-robin technique, it was using just everything at once. We can see that there was 300 ticks during that time. So there was the tick rate was 0.1 seconds. So for 30 seconds that looks right. And our inclusive time is 92.4 milliseconds. And then if we go to the other section over here, so this, let's do a 30-second window here as well. Okay. There we go. So yeah, two different snapshots there. You can see that we're using a there's way many ticks now. We're at 71 milliseconds now. So there's a smaller inclusive time by using the round-robin technique when we're just doing things like drawing debugging. Okay, so now that we've established that the concept kind of works with drawing spheres, let's see if it works with actually setting something that we would do in audio, which is like set a surface type. So we're going to do a line trace, and then we're going to set a surface type. So first off, we will do the non-round-robin technique. So we'll just stand here for about 30 seconds. That should give us a large enough window. Okay, there we go. And then this time we're going to do the round-robin technique. So we need to hook up the begin play, which does the divide, and then do this. So this time it's going to do the round-robin. And again, we're just going to sit here for 30 seconds. Okay, there we go. And then we can check out those results. Okay, so here is the profile for the round-robin technique using the setting of the physical material. So with the round-robin, what we actually find is that because we're setting this physical material so many times that it's actually got a very large value. So we can see that it's doing all of these things like get location at spline point, get surface type, especially the line tracing. The line tracing has a big impact on this. And then when we compare that to the one that does it all at the same time, you can see here that there's only 41 milliseconds, which is interesting because drawing the debugging was cheaper, but the things that we're doing in the loop that are spread is actually way more inefficient. So I guess, just make sure that you do your tests. Just because it works for one kind of feature doesn't mean that it would work for all features. Just something to think about as well is there's still merit in this. Like, although we were doing line traces so quickly, it is still an option to spread the load, but just increase the duration between those updates. So rather than dividing it by 10, we could probably leave it at the same amount, and then that way we're still spreading the load across the frame, just in a much larger fashion to bring that performance back into line. That way, we're not doing 10 updates on one tick. We're doing it across multiple, which can, if you can afford to buy the time to do that, then that's probably a good thing to do.